We're starting with Lesson 58, Tangents and Circles, Part 1. This is located on page 381 of Saxon Geometry. In a circle, so far we have already explored terminology of a radius, a diameter, which is a chord, a special chord through the center, a circumference, pi, which is how many times the diameter can be wrapped around the circumference, a chord, which is a segment, a secant, which is a line, a central angle, minor arcs, and major arcs. A tangent line, or also called a point of tangency, which was covered in Lesson 43. All of our special terms relate to points, lines, and segments inside the circle. A tangent line resides outside the circle with only one point relating to the circle. In this drawing, we have a circle C, with C at the center, a radius, a point of tangency of B, and AB, or AD, is the name of the tangent line. To begin with, the theorem 58-1, if a line is tangent to a circle, it is perpendicular to a radius drawn to the point of tangency. So, in written terms, the radius, labeled CB, is perpendicular to the line AB. This tells us that the angle of ABC is 90 degrees, and the angle of CBD is 90 degrees, with B being the tangent point. Example 1 mentions that if we have circle C, and if we get given that the measure of angle CQP is 36 degrees, our job is to determine the measure of angle PCQ. Well, by theorem 58-1, CP is a segment which is perpendicular to line N. Therefore, this angle is 90 degrees. And if that means that PQC and CQP are complementary, so 36 plus this angle are 90 degrees, which makes the measure of PCQ 54. Along with that, very similar to it, is stating that we can learn the other thing, and we can learn the converse. If a line on a plane of a circle is perpendicular to a radius, the radius's endpoint on the circle, then the line is tangent to the circle. So this is telling us that line QP is tangent to circle C. We're going to combine this and say they are converses of each other. Logic shows that they create a biconditional statement. A line on a plane of a circle is tangent to the circle if and only if it is perpendicular to a radius which is drawn to that point of tangency. Now our example wants us to prove that angle by identifying tangent lines, or by defining them, by asking ourselves if it is a tangent line. So in this example, the measure of angle BEA equals 45 degrees. BEA. We need to show that BD is tangent to circle C. Well, we can see that in this drawing we've been given other information. We've been given that AC is congruent to CE in the first line. We've been given the measure of AC CE is 90 degrees. And triangle AEC is isosceles, which means that the measure of CAE is congruent to the measure of CEA. Because they are congruent, acute angles of an isosceles triangle are 45 degrees each. For they must be complementary, and they're equal. So 2 times the measure of one of them equals 90. So they are equal to 45. So going back to those 2 angles right here, I'm going to label one of them 1, one of them 2. Tells us that angle BEC, this is my first time trying this. This angle right here, with the knowledge that we now have that CEA is 45 and BEA was given at 45, we have that 45 degrees plus 45 degrees equals 90 degrees, which tells us that now we have shown that BEC is perpendicular. Therefore, by theorem 58.2, because it's perpendicular, BD, the line, is tangent to circle C. That's pretty good. Now, we're going on for what's easy. At this point in our lesson, I would like you to start a smart sheet. The smart